So I finally received the pre-crimped JST connectors from Amazon that I was talking about in the last few videos. This will make my life so much easier as I work out a wiring harness for the final coinbot. But before I do that, I need to make sure that all of the wiring that I've worked out so far is still connected correctly. This board that I created, this temporary setup that I created, has gone through a couple of different moves now, and I want to make sure that all of the wires are connected properly. We have a little script running on the Raspberry Pi that I can use to test all of the lighting, the stepper motors, and the limit switches that control the stepper motors. And I want to make sure that everything is working before I try to wire up everything permanently and solder the connections actually permanently to the board. Now, the brains of this whole operation is a Raspberry Pi with, I think, 4 GB of RAM. And on top of that, there is a motor stepper hat that is resting on top of the Raspberry Pi. And that is what I'm using to control the stepper motors. Now, attached to those are 2 limit switches. Those limit switches get pressed, and that's how we will know how to home each one of the stepper motors. But if everything is working properly, the stepper motor should spin. And when we press each one of those limit switches, the stepper motors attached to it should turn off. Now, if we scroll down here in the code, we can see which pins are controlling the 2 limit switches. Right here, we can see that the top one is pin 22, and the other limit switch is controlled by pin number 13. And before we actually inspect anything, of course, I need to put on my glasses because that makes me about 50% smarter. But anyway, let's check those 2 pins and make sure that the limit switches are connected correctly. I can see that one side of the limit switch on top of this stepper motor is plugged into ground, which is appropriate, and the other, the blue wire, is plugged into pin 13, which is correct. On the other limit switch that's attached to this stepper motor, I see also that one wire, the green wire, is plugged into the ground rail, and the other one is plugged into pin number 22, which is also correct. So that means that those 2 limit switches are plugged in correctly. The 2 stepper motors are connected to the stepper motor hat that's attached to the top of the Raspberry Pi. And since those use screw-down terminals, I know that they are wired correctly, so I don't have to touch those. The next thing we need to check is to make sure that the addressable LEDs are connected to the correct pin. And again, if we go back to the code, we can see that the pixel pin on the board is pin number 10. That's shown right here. So we need to go back to the addressable LEDs and make sure that the data wire that's connected to those is actually attached to pin 10 on the Raspberry Pi. Pin 10 is the MOSI pin, so I need to make sure that the LED, the addressable LEDs that control the Coin Studio lighting are attached to pin number 10 on the motor hat. So I will do that now. I also need to check the CPU fan to make sure that it's connected to both the positive and negative terminals on the 5-volt rail of the breadboard. And that all looks good here. I can see that the black and red wires are connected. And then I'm going to connect the breadboard's 5-volt rail to the stepper motor hat 5-volt rail and make sure that those are interconnected. So I just connected the 5-volt rail of the breadboard with the 5-volt rail of the motor hat that's attached to the top of the Raspberry Pi. That means that the motor hat will be supplying 5-volt power to the breadboard and to the addressable LEDs that provide lighting to the Coin Studio that I have in this pill bottle. That 5 volts is ultimately coming from the benchtop power supply that I have here on my desk. The last thing we want to do is just run the test script on the Raspberry Pi to make sure that everything's working correctly. If everything's working as it should and everything is electrically connected properly, that means the LED lights should light up and then the 2 stepper motors should start spinning. They should also turn off when we press these limit switches. So let's give it a test and see what happens. We'll run the script here. You can see that the LED lights turn on and they go through a series of different patterns. And then the stepper motors turn, which is great. So you can see this stepper motor here is spinning. And when I press the limit switch on top of it, it shuts off. Now this stepper motor is still spinning. And again, when I hit the limit switch on top of that, it also stops. So all of that is perfect. The only thing that I see here that's a problem is that the LED lights still remain lit after I've stopped the script, and they really should be turning off. I think that's the result of a ground issue here with these wired connections. And I'm hoping that goes away in tomorrow's video when we create a finalized wiring harness for the coinbot and eliminate any of those grounding issues by permanently soldering the wires directly to the hat that's on top of the Raspberry Pi. But I think that's enough for this video. And as I've said in the last few videos, if anyone has any feedback for me about how I can do a better wiring job for the coinbot or make better videos, please leave a comment down below. But for now, that's my 2 cents. Thanks for watching, everyone. Stay awesome.